Welcome along, explorer. It's time for a brand new journey all around the universe. We are heading past Pluto, having an adventure through Andromeda, and we're going much further in search of all the smart stuff. It's a brand new Fun Kids Science Weekly. My name's Dan. This week, on the greatest show in the universe, we're looking up at the sky. Have you ever done that? Really search the sky and you've been wondering, why is it so blue? Today we'll find out.
And the shorter wavelengths, that's your purples and blues, they get scattered more strongly because they're only little, so they get pushed out the way more. And that means when you look up at the sky, you'll see more of that blue light because it's being pushed around more everywhere.
Also, we'll discover if food really does taste better when you're hungry, and we're blasting deep into the universe to hunt for another planet just like ours.
Turns out, in the universe, there's just all kinds of stuff there. Jupiter-like planets, really, really close to their star. We name those hot Jupiters. Then we have these lava worlds that I spoke of. Again, things a little like the Earth, but super hot.
It's all on the way in a brand new Fun Kids Science Weekly. Let's start with your science in the news. William, the Prince of Wales, has revealed the 5 winners of this year's environmental Earthshot Prize, saying they're an inspiration that gives everyone courage. The awards ceremony was in Rio de Janeiro in Brazil, and this eco-award flew in celebs and pop stars and politicians from all around the world to see what the winners have done. The victors were given £1 million to scale up their idea to help our climate. There were prizes for a team that want to make clean air zones in Bogota, that's the capital of Colombia. Also for plans to revive our oceans and conserve marine life, and how to make the Lagos Fashion Week in Nigeria sustainable. All sorts of ideas, not just the big stuff, but also focusing on little things that we can do to tweak to change our climate. And I think £1 million, it's a brilliant amount of money, and having actual royalty there and so many famous celebrities, it just encourages people to try and do their bit. So I think this is a fantastic idea. Also, the very first humans may have been inventors. That's according to a new discovery in Africa. Researchers at an archaeological site in Kenya have found that primitive humans that lived almost 3 million years ago used stone tools for 300,000 years. Now, we knew that early humans used tools, but experts thought that it happened here and there, that the use and the idea sparked up quickly and died off, and the skill was soon forgotten. But new tools found seem to suggest and show that generations passed on this skill to their children, which carried on and on and on for 300,000 years, using tools like hammerstones and flakes, sharp flakes and stone cores. You'd make them by striking rocks against other rocks gathered from the riverbeds, and the fact that we were doing that all that time ago for such a long span, I think it's brilliant to know just how intelligent we've always been. And our final story this week, a glowing shark and a see-through crab have been discovered by scientists deep down in the Australian seas. The 2 new species were discovered as part of a big research mission by the science agency down under, CSIRO. Now, Dr. Will White is a fish scientist and can join us. Will, thank you for being there. Now, in this research, experts found, 20 new species underwater. Why has it taken us so long to discover them?
A lot of it is to do with just the areas that we've previously surveyed. On that particular survey off northwestern Australia, we were able to actually collect samples down to 5,000 metres deep, and nothing had ever really been done below 2,000 metres, so we're starting to see more deep water species coming in.
Now, 5,000 metres is fairly deep, underneath 5k down underneath the ocean. How tricky is it to find species down there and to be able to identify what they are?
Yeah, certainly for fish, there's very few fish species that live down there, but what is down there is poorly known. It does take a long time at that depth. We'll be looking at 7-hour deployments for including sort of cable going down and cable coming up. But then often it was the sort of escarpments as you get closer to the shallow areas. coming up around the 1,000, 2,000 metre mark is where a lot of the sort of fish diversity really kicked in.
Now, scientists, you must have a big, thorough knowledge of the species that exist. How do you know whether we've discovered this animal before? Is there some kind of Wikipedia all about them? Is there a huge database?
Yeah, there's definitely big databases. In Australia, we have our own sort of system catalogue, but it basically all sort of connects into international databases. But you largely rely on just the expertise you have on board. So for that particular expedition, we have about 25 scientists from all different agencies around Australia, and we're currently out at sea again now in the Coral Sea on the same vessel and have about 25 scientists as well there.
Well, now, I know that it's 20 or so creatures that you've found, but it's the glowing shark and this see-through crab that have really caught my interest. Just tell us a little bit about those.
Yeah, so I won't go into too much detail with the crab because that was actually colleagues of ours from West Australian Museum on the same voyage. I don't know too much about, but yes, they definitely found those few new species of porcelain crab. Part of what I was working on, I mainly work on sharks and rays, and yeah, one of the new species was a lantern shark, as well as a striped horn shark and a demon cat shark that we found that were new species. And yeah, the lantern shark was just described recently.
So this lantern shark, it's about 0.5 metre long, is that right? What does it look like? How does it glow in the dark? What are his eyes like? Just tell us a bit. Yeah,
so only about 30 or 40 centimetres long, so one of the smaller species of sharks. There's actually a lot of lantern shark species in the world. We have over 30 species. But they're sort of, they swim off the bottom, usually near the bottom, but they can swim quite a way off the bottom, but they're almost torpedo-shaped, elongate, and one of the most amazing things about them is they have these organs on the side that contain lots of bioluminescent organs that just sort of flash. So when you sort of see them, if they're captured or seeing them on photos, you just see these black marks. But if you look really closely at them, they contain lots of these different, they're called photophores, and they can be all different colours, from bright blue to bright greens. And they're used just for attracting prey and things like that. So you're quite an amazing group of animals.
And you're out on the ocean now, trying to find new creatures, doing research. How do you know when you're done? Are you there for a few months? How does it work? Do you just one day decide, right, we found enough, let's go home? How does that happen?
No, we have it's a very competitive process to get sea time. So, probably a few years ago when I first started applying, we came up with a sampling design of 35 days to cover the area that we wanted. We're about halfway through that 35 days up here now. But yeah, they take many years to organise these sorts of voyages, and we'll spend probably 2 or 3 years after that voyage working through all the data. And then we usually have other voyages going in that time and continually. So we're always continually working up because each voyage will contribute to previous voyages as well.
Well, it's been a real treat to have some of that time to chat to you, Dr. Will White. Thank you for joining us.
Oh, thank you very much.
All right, thank you so much to Will White for coming on the show, helping us learn all about that brand new glowing shark that we've discovered. It's not new, it's been around for ages and ages and ages, but we've only just started to find it. We'll dive under the ocean again in a little bit for another amazing animal with today's Dangerous Dan. Right now, let's get to your questions, shall we? If you ever have anything sciencey that you want answered on the podcast, the best thing you can do, leave it as a voice note for me on the free Fun Kids app and at funkidslive.com. That's my favourite way because then you can star on the show and I know exactly what you mean and I can get a genius on to answer it for you. First question this week, it's from someone who's left a review for the show on Apple Podcasts called Podcast Guy 14, who wants to know, why does food taste nicer when you're hungry? Think about this. It does, doesn't it? Food does taste nicer when you're hungry. I always thought it was down to the expectation. You know how you feel really happy on your birthday as soon as you wake up, but it's because you've waited so long for it. I thought it was a similar thing. I didn't think there was any kind of chemical or hormonal change in your body that actually made food taste nicer when you're hungry. I thought it was all down to expectation. And it turns out I was wrong and a little bit right. There is some very smart science in there. First, let's talk about the contrast effect. So if you've been waiting for food for a while, the contrast, the difference between being hungry and being full makes that food seem more delicious because, you've finally eaten. You know when you scratch an itch that's been niggling at you for ages? Makes you feel really good, right? It's because you've not got that itch anymore. So so that is happening when you finally eat. We've got the contrast effect. Also, being hungry activates the brain's reward circuits. It wants something. So when you eat, you get a strong pleasure, happy response, a big spike of dopamine. That's the pleasure hormone in your body. So you feel happy, and that makes that food taste nicer because your brain is rewarding you for eating, and that will come back in just a second. There is very smart science in there. It's all to do with another hormone called ghrelin. Now, ghrelin is the hunger hormone. It tells your brain to feel hungry and to boost your appetite because you need food, and this hormone senses that. But in doing so, it also boosts your sense of taste and smell. So when you eat, food smells stronger. You're being more receptive to those senses. It tastes bigger. And if you're loving the meal, well, you love the smell, you love the taste, so that means it's all nicer. Now, it does that, so you get the dopamine, the pleasure hormone, so you recognise that eating is good, because humans have evolved the need to eat food to live, so you need to enjoy doing it, otherwise you wouldn't do it, and then humans don't grow. So all of those hormones and all of those chemicals work together to make sure you are eating as often as you need to. Podcast Guy 14. Thank you so much for the question. A lot of smart science in there. Let's get on another one, shall we? Brilliant. It's a voice note been sent in from Marcus. What do you have, mate?
Hello, I'm Marcus. I'm 4 years old. Why the sky is blue?
Well, Marcus, thank you so much for your question. Why is the sky blue? Is it actually there? Is it a real colour? Is it something to do with our eyes? Shall we find out? With a good friend of the show, meteorologist Kirsty McCabe joins us. Kirsty, thank you so much for being back. Anything at all to do with the sky or what comes out of it, we turn to you. And today, the colour. Why is our sky blue?
Oh, thank you for having me. Well, the simple reason the sky is blue is because, well, we all know that sunlight actually looks white, but it's made up of all the colours together. And you might have done experiments at school where you split light up using a prism, a glass triangle that splits up into different rainbow of colours. So we know that. We also know that light travels in waves, and each colour has its own wavelength. So red wavelengths are longer, it's more stretched out, and the blue ones are squashed close together. They've got shorter wavelengths. And when the light from the sun comes into our atmosphere, it bumps off little particles, little tiny molecules of nitrogen and oxygen, little gases in our atmosphere. And that pushes the light around, so it deflects or scatters the light. And the amount they get scattered depends on the wavelength. And the shorter wavelengths, that's your purples and blues, they get scattered more strongly because they're only little, so they get pushed out the way more. And that means when you look up at the sky, you'll see more of that blue light because it's being pushed around more everywhere. And it's a similar thing as to why the sky's red at sunset and sunrise. Do you want to know a bit more about that?
Yeah, that was my next question. Yeah, what's happening there?
We're on the same wavelength there. So the reason that the sky takes on these lovely pinks and reds and oranges is because at dusk and dawn, the sun is much lower in the sky. And so it travels through a bigger slice of the atmosphere to reach us. And while that light's traveling through, more of these blue lights are scattered away. So instead of reaching our eyes, they're scattered away from our eyes, but the longer oranges and reds get to the eyes. And so that means we're left with those. When the sun is lower in the sky, we see more of the reds and the oranges, which a lovely treat for your eyes at the beginning and the end of the day.
In the middle of the day, Kirsty, so when the sunlight is hitting all of the different particles and the blue light, well, all the light's getting scattered. So we can see loads more of the blue light. Are the other colours, the other waves of light?
Are they still there?
Could we see them if we tried?
They're still there. It's just that the blue light's scattered more strongly, so you're seeing more of that. And interestingly enough, it's kind of similar with our eye colour, that our eyes aren't actually a colour. We just see them as a colour because it's all to do with how your iris is reflecting and diffracting the light away from it. So people with blue eyes, it's almost a similar way to why we're seeing the sky as blue, just because it's scattering the wavelengths more depending on how much pigmentation is in your iris.
What? I mean, that's a mind-blowing. So there's nothing I've got blue eyes, but there's nothing physically blue
We don't. We just see them as blue. That we'll need to get a medical expert on next to back this up. But that's what I've heard. Similar thing to the sky looking blue to us is the same thing as eyes looking blue.
Wow, that's unpacked so much for us. Marcus, thank you for giving us the excuse to do that. And as always, an absolute joy to have Kirsty McCabe on. Thank you for being there, Kirsty.
No worries. Hopefully we'll see more blue skies soon.
Always great to get Kirsty McCabe on the show. Marcus, thank you very much for your question. And if you have anything sciencey that you want answered on the podcast next week, make sure you leave it as a voice note for me on the free Fun Kids app. You can do it too at funkidslive.com. It's time for this week's Dangerous Dan, where we search all around the universe. We find the weirdest, most unique and strange and often deadly things out there. This week we're heading under the ocean to meet nature's living battery. The electric ray is a flat fish. Looks a lot like a stingray. It's related to sharks too. Normally they're a brownish tan colour. They blend in with the sandy seabed because they're ambush animals. Found usually in shallow coastal waters across the world. So they're wide, quite thick. They've got quite a chunky tail. It's not usually thin, needly like other rays. They're nicknamed Nature's Living Battery. They're named the Electric Ray because they've got special organs on either side of their head that make huge electric shocks. Up to 220 volts of potential there. These sharp surges can stun or kill a fish instantly. 220 volts is the same level of potential electrical power found in homes all around the world. Powering plugs. So it's a big charge for this ray. They move slowly, they look harmless, they bury themselves in the sand to ambush prey. They stun a fish. They munch on what they've zapped. If a creature touches the top of their body, zip! It gets surged, it gets zapped, it gets stunned. Now for humans, that gives a painful jolt, causing muscles to spasm and quiver. And ancient Greeks actually used them as a numbing device for pain relief way back thousands of years ago. For fish, it's a pretty bad time. It means they're going to be dinner, and that's why Nature's Living Battery, the electric ray, goes straight onto our Dangerous Dan list. It's time for Battle of the Sciences, where we try to figure out what's the greatest science in the history of the world. And this week, we're going outside of the world. We're talking about exoplanet astronomy with Dr. Annelies Mortier. Now, Annelies, you have 1 minute to tell us why exoplanet astronomy is the greatest science of all. That minute starts in 3, 2, 1, go!
Exoplanets is the name we use for planets that are around stars other than the sun. So we know about more than 6,000 of these exoplanets in the universe, which is quite cool. We find them by basically, amongst others, looking for a star to wobble because the planet pulls on its star. Many different planets have been found, and it's actually a wonderful variety, and including planets where you could celebrate your birthday every day, so that's quite fun and cool. I personally look for an Earth twin planet, which is basically a planet that would be just like the Earth, orbiting a star just like the Sun, where you celebrate your birthday only once per year. If we find such a planet, then obviously the question becomes, could there be aliens there that are also just like human beings? So that personally, in my very biased opinion, I think that exoplanet astronomy is actually the coolest science in the world that you can do.
Annelies, thank you so much. Did you say we found 6,000 exoplanets?
Yeah, a little more than that, but yes.
So that's pretty good going, considering we've only been able to look across the universe for a couple of hundred years. But what I kind of struggle to understand is that why is it taking us so long to find these different exoplanets? We have the technology available to us. Why can't we just look in a telescope and see some more planets really simply?
So despite being able to look in the universe for a couple hundred years, exoplanets have only been found roughly 30 years ago. We recently celebrated the 30th anniversary of the first exoplanet around the solar type star. The reason that it's difficult is because the planets themselves don't give any light that we can see usually. So we have to look via the small, very tiny effect they have on their stars. And whilst the technology is there, it's a very, very difficult measurement to make. It's not like you can just take a picture and there's your exoplanet. These are very difficult measurements to make, very time-consuming measurements to make, and we often have to go to space or to faraway observatories in order to make these measurements.
And your speciality is looking at Earth-like exoplanets. How on earth can we? How can we know enough about an exoplanet light years away to decide whether it's like Earth or not? How do we find that out? And what signs are you looking for?
Now, that's a very good question. So the things that we can measure is how far away from their star they are, which would allow us, for if nothing else, to know roughly what the temperature would be on that planet. We also have measurements that allow us to tell what the radius or the size of an exoplanet is. And then, of course, if it turns out that it's roughly the same size as the Earth, that tells you something. And then we also have measurements that allow you to have the mass of a planet. So recently, we have been finding some planets with the same size as the Earth, the same mass as the Earth, but much, much closer to their star. So it's much, much hotter there, and it's probably more like some sort of out-of-control lava world. But that's where we start. We start with the basics, the mass, the radius, the period, and then down the line, we try to get information of a possible atmosphere.
You said that some of these exoplanets, we would be able to celebrate our birthday every single day, I imagine, because they're orbiting their star very, very quickly. What other amazing things have we learned about these unique exoplanets?
The biggest thing we've actually learned, in my opinion, is that there's planets everywhere and they come in all kinds of shapes and sizes. Well, not shapes, they're all spheres. They come in all sizes and all masses. So there's such a wide variety, whereas here around the sun, we have the small planets like Mars, the Venus, the Earth, the Mercury. And then we have the ice giants and a couple gas giants. And we sort of thought those are the types of planets you can have. Turns out in the universe, there's just all kinds of stuff there. That we have Jupiter-like planets really, really close to their star, much, much closer than Mercury is. We name those hot Jupiters. Then we have these lava worlds that I spoke of. Again, things a little like the Earth, but super hot. And then we find all these planets with sizes and masses somewhere in between the Earth and Neptune. We don't have things like that, but we keep finding them, and they're everywhere. And it's actually mind-boggling to try and understand what they're made of, because the solar system doesn't have them.
And if you're looking for Earth-like exoplanets, I guess one of the reason is we want to try and find out if there is life that, as we know it, outside of planet Earth. How close do you think we might be to discovering that once and for all?
The other reason why you would look is also to know if a planet like the Earth, where we live and where we know life exists, then how unique that is. And you can really only answer that question by trying finding more or having the ability to say, okay, we looked and they're not there, so that must mean we're unique. Now, we're closer than you might think. I personally think that in the next decade, we'll start to either have found someone as a planet like the Earth, or the ability to start ruling things out and finally putting some numbers on how common or unique is a planet like the Earth. Then the question of life, well, that will probably take a while.
Annelies, we always finish these in exactly the same way. Let me throw you forward years and years and years and years towards the end of your career as an exoplanet astronomer. What's the one question that you'd love answered? What do you really want to know in your science?
What I really want to know is what I just said, how common or non-common is a planet like the Earth or a system like the solar system, where everything is nicely lined up. It would be wonderful if we could find signs of life by the end of my career, but that's not the biggest thing I'm looking for.
Well, it's been a real joy to search through the solar system and, well, much further beyond with you, Dr. Annelies Mortier. Thank you so much for joining us.
It's my pleasure.
Earlier on in the show, we had one of our favourite geniuses, Kirsty McCabe, on, proper meteorologist, talking all about weather and what makes the sky blue. Well, we can head further up than the sky right now, taking a lesson from one of the smartest schools in the solar system. We're headed to Deep Space High, where Sam, Stats and Quark, they're finding out all about the different types of space weather, from magnetic storms, cosmic rays, solar wind and coronal mass ejections. Sounds like something you might need a medicine for.
Deep Space High, Intergalactic Weather Watch.
Jump into a wormhole and travel to Deep Space High, the school in space. But hurry, because lessons are about to begin.
Alright, settle down. Hey, where's Quark?
Must have missed the space bus.
Not again. Okay, today we're going to check out some different types of space weather. Let's remind ourselves about where a lot of it comes from. Buckle up and sunglasses on. This is the Earth's sun. It's constantly sending waves of energy to the planets in its solar system, and a good thing it does. Life on Earth would be impossible without the light, heat and energy it provides. In fact, this energy is so strong that if it wasn't for the magnetic field around Earth, it would be harmful.
So does the magnetic field act like a shield? Man, that's bright.
Pretty much. All this movement of energy is called a solar wind. Now, if I just tweak these filters, there, you can see it for yourself. Normally, solar winds are invisible, although there's one way you can see them. Near the Earth's poles, the energetic particles react with oxygen in the atmosphere and create things called aurora, beautiful rippling coloured waves in the sky.
That's so pretty.
Solar winds travel at different speeds depending on where they originated on the sun. Winds from the top and bottom travel much faster than those from the middle. The really, really fast winds are known as high-speed solar wind streams. Luckily, they usually blast up or down, and not towards planet Earth.
Which is probably a good thing, because that's one kind of wind you wouldn't want to get caught in.
Okay, settle down. Now, as we've seen, the sun is a big, bubbling, moving mass of gases and plasma, and every now and then, there's a solar flare. And if I'm right, 3, 2, 1... Hold on tight! A solar flare is an outburst of radiation and energetic gases. They are pretty common, almost daily occurrences, and don't have much impact on life on Earth. Sometimes these flares can affect things like satellite navigation systems, but generally their impact is small. However, sometimes things get a little more dramatic. Yeah, you're gonna need to tighten those seatbelts. That's a coronal mass ejection. It's a high-speed burst of denser material that's ejected when the magnetic fields in the sun's atmosphere become unstable. This makes the solar wind turbocharged as it races through the solar system. Coronal mass ejections are so strong that they can break through the Earth's magnetosphere, creating magnetic storms, and that's when the Earth's magnetic field is disrupted. And as a result, electric currents become intensified, and anything that relies on electricity or magnets can all be disrupted. These magnetic storms also heat the upper atmosphere, which can affect radio transmissions. And that means wireless technologies such as satellite navigation, wireless internet and mobile telephones.
Oh no! How will we cope without mobile phone and Wi-Fi?
Okay, most coronal mass ejections don't affect things too badly, but a really large one can. The largest ever recorded space weather event was in September 1859. It's known as the Carrington event, after a British astronomer who observed the solar flare. It caused auroras to be seen over the Caribbean.
Whoa, that must have looked amazing! Although you shouldn't look at the sun directly.
That's right, Stats. You can damage your eyes and blind yourself.
Sorry I'm late.
Where have you been?
I missed the bus. And then there was a supernova, so we had to wait for ages to take a detour via the Large Magellanic Cloud. Typical.
Well, supernovas have something to do with space weather too. Some solar winds which reach Earth don't come from the sun. Check out these galactic cosmic rays. Supernovae are large explosions which occur when stars collapse. They send electrically charged particles far into space, again interfering with electrical equipment they come across. I'll kick the filters on and you can see for yourself. We'll be back in Earth's orbit in no time thanks to this solar wind. Luckily, really big events are rare, and next lesson we'll look at how scientists predict space weather. And I predict that it's the end of the lesson. Class dismissed.
Deep Space High, Intergalactic Weather Watch, with support from the Science and Technology Facilities Council. Find out more at funkidslive.com/space.
Always amazing to get a lesson up at Deep Space High. If you want to hear more from Sam, Stats, Quark and the gang, Professor Polestar too, you can find Deep Space High wherever you're listening to this. We've got it on the free Fun Kids app and at funkidslive.com too, with loads more brilliant podcasts there on Google, Apple, Spotify and all of those fantastic places. If you have a question that you'd love answered on the show, make sure you leave it as a voice note on our app or on the Fun Kids website. And Fun Kids, we are a children's radio station from the UK. You can listen all around the country on the app, over at funkidslive.com. And if you've got a smart speaker, wake it up and ask it to play Fun Kids, and I'll see you next week.